Logarithms. Well, one specific application is the Richter scale that measures the intensity of earthquakes. It has to do with logarithms, base 10, fun stuff like that. There are some applications in electricity that have to do with logarithms. Those are just two off the top of my head. All right, so here, let's look at the properties. We have three properties that you need to know. The first one is the product property. When you're taking the log of a product of two numbers, two variables, a number and a variable, whatever it may be, you can split that up into a sum of two logarithms, or vice versa. If you're adding two logs that have the same base, if you're adding them, then you can condense them into a single logarithm of the product. The quotient property, and the way that I kind of remember these is I kind of relate them to my exponent rules, okay? When you multiply like bases, what do you do with your exponents? You add them. So when you're multiplying within a logarithm, you add the two logarithms, okay? Quotient, when you are dividing like bases with exponents, you subtract the exponents. So when you're dividing within a logarithm, you can expand that into the difference. And it's always the top one comes first, the bottom one comes second, or vice versa. If you're subtracting, you may need to condense them. It just depends on what the instructions are. And then the power property is very useful. You can take an exponent and it comes down and becomes the coefficient component of the logarithm. Okay? And these same properties apply to the natural log as well. So we can use these with the log and the ln, okay, common log and the natural log. These are applicable to both. Okay, so the first thing that we're going to do is we're going to expand some expressions. Okay, flip your paper over, we're going to expand some log expressions using these properties. So the first problem that we have here is log base 4 of 5x cubed y. So we are going to expand this single logarithm into several logarithms. So we're multiplying these three terms. So that is the log base 4 of 5 plus the log base 4 of x cubed plus the log base 4 of y. Now y'all like to get lazy on me and you don't like to write the base. Guess what? It's wrong. Because if you don't write a base, then it's understood to be 10. This is definitely not base 10. This is supposed to be base 4. There's a big difference. Okay? Now, the purpose of expanding would be to evaluate something without a calculator. So, if we knew, say for example, that wasn't log base 4 of 5, say that was log base 4 of 16, okay? We know what log base 4 of 16 is. It's 2 because 4 squared is 16, okay? So that's one of the purposes of this. There's one more thing that we can do to expand this. We have a power right here. So that middle logarithm, we can move that power of 3 in front of the log. And this is now fully expanded. Okay, it is fully expanded. We have moved all of our exponents. We have a log of a single term within each of our logarithms. Okay, that's when you know that you're fully expanded. All right. Let's look at example B, the natural log of the square root of 3x minus 5 over 7. So first of all, we have a quotient. So a quotient can be expanded into the difference of the logarithms. Okay. Now, it may not look like we have a power, but can we rewrite the square root so that it's an exponent? How about the 1/2 power? Okay, the square root can be rewritten as the 1/2 power. So then we can apply our power rule to bring that power in front of the logarithm. 1/2 natural log of 3x minus 5 minus the natural log of 7. That's as far as we can go. Okay, we cannot break this logarithm up. The only way you can break up logarithms is when there are products and quotients within the logarithm. Okay? This is a difference within the logarithm. And since there's a difference, we can't split up the 3 and the x. Okay? So that's as far as we can go with expanding that. Okay, so try this practice problem right here. Log base 3 of 4x squared over the square root of y. I want you to expand that using these properties. Expand it as much as you can. Log base 3 of 4x squared over the square root of y. Okay, did we get this? Log base 3 of 4 plus 2 log base 3 of x minus 1/2 log base 3 of y. Any questions about that? Okay, so just make sure that we've got these